Hello students, welcome back to the fifth video of this playlist. So in this video we will be solving the fifth question from P1 May 2024 paper. So let's see what's the question number 5 is about. So basically the concepts behind question number 5, it has been discussed in chapter number 6 and chapter number 7, that is trigonometry and radians chapter of your P1 book. So in order to be able to solve this question number 5, definitely you have gone through chapter number 5, chapter number 6 and chapter number 7 of your P1 book. So let's get started with question number 5. So right at first in question number 5 you can see a figure of, basically it's a figure for a view of a garden, that is figure number 2. Okay, so it's figure 2 shows the plan view of a garden. Okay, the shape of the garden ABCDEA consists of a triangle ABE. A triangle ABE, where's the triangle? This is the triangle ABE, a scaling triangle, this triangle. Okay, and a right angle triangle BCD. This is the right angle triangle, okay, BCD, joined to a sector BDE. Where's the sector BDE? Has the sector BDE. Okay, it's a sector of circle with radius 6 cm and center B. B is the center. Fine. Okay, the points A, B and C lie on a straight line with AB. The point ABC, you can see this lies on a straight line with AB. The length of AB is what? 10.8 meter. Okay, so angle BCD is given pi over 2 radian, that is right angle triangle. This triangle like BCD, this angle, and angle EBD. EBD is given this one. It's 1.3 radians. And AE equals to 12.2 meter. The length of what? AE. The side AE of the scaling triangle. Okay. Now the first question is asking, find the area of the sector BDE, giving you answer in meter squared. Okay. We need to find out the area of the sector BDE. Okay, this is pretty straightforward question. Sector area. Definitely you know the formula for sector area, or otherwise I guess it will be given on the formula booklet also. Let's check it out from the formula booklet. The formula for sector area is half r squared theta. It might be given in the formula booklet. Unfortunately, no, it's not given in the formula booklet. So definitely you should have memorized this formula, area of a sector. Area of a sector, this is what? Half of, it's not given in the formula booklet, half of r squared theta, where theta should be in radians and r is the radius of the sector. Okay, so we will need to use this formula in question number 5 part A to find the area of the sector BDE. Okay, so let's find out the area. Okay, so area would be what? Area of sector BDE, right? BDE, this is what? Half r squared theta, right? Half of, what's the radius? Radius is 6, so 6 squared is 36. And theta, what's the theta? Theta is the what? Angle. This is the theta, 1.3 radian, right? The angle between the two adjacent radius, that is 1.3 radians. Okay, 1.3 radians. Okay, this should be C. Okay, so what would be the value? We need to give our answer to meter squared. Okay, so half of 36, that is 18 times 1.3, so that would give you 23.4 meter squared. Okay, so that is 23.4 meter squared. Okay, that's the answer for part A. Okay, next, part B. Find the size of angle ABE. We need to find out the size of the angle ABE. Where's the angle ABE? Let's figure it out. ABE, this is the angle. Okay, this is considered this as theta. We need to find out this angle. Okay, so giving you answer in radians, we need to give the answer in radians to 2 decimal places, 2 dp. Okay, so if you see the triangle, this is a scaling triangle. That is none of the sides are equal. So we know but we know the length of the 3 sides, isn't it? So definitely we can go for which rule? The cosine rule. So I just checked it, like in the part A, we checked the formula booklet. So cosine rule will be given in the formula booklet. Okay. For part B, we will be using the formula booklet. So for cosine rule, actually you don't need to memorize any formula like sine rule, cosine rule. Just get used to the formula. Okay. Keep in mind, in maths, don't memorize the formula. Get used to the formula. If you just keep memorizing the formula, it won't work. Maths is a subject. It's all about practice. The more you practice, the more better you will be. So here we need to use cosine rule, the formula, right? So you need to get used to that cosine rule formula. You don't need to memorize it. Okay. So how can we get used to that formula? Look, consider like this: cos theta. We need to find out the cos theta. So cos theta equals to the sum of the squares of the 2 adjacent sides. Okay, so the sum of the square of the 2 adjacent sides. So what are the 2 adjacent sides here? 6 and 10.8. So sum of the square of the 2 adjacent sides, that is 6 squared plus 10.8 squared minus what? Minus the square of the opposite side. So what's the opposite side of the angle theta? That is nothing but 12.2. Okay, so that would be what? 12.2 squared minus what? 12.2 squared over what? Twice of the length of the 2 adjacent sides, that is 6 and 10.8. If I tell you again, cosine rule is basically cos theta is equals to in the numerator it will be the sum of the squares of the length of the 2 adjacent sides. So that is 6 squared plus 10.8 squared minus the length of the opposite side to the theta, that is 12.2 squared, over in the denominator it would be 2 times the product of the length of the 2 adjacent sides to the theta. Fine. Now we need the value for theta. Okay, so theta, if you were finding the value for theta, that would be what? 6 squared, that is 36 plus 10.8 squared minus 12.2 squared over 2 times 6 times 10.8. so that is 19 over 648. Take your calculator to radian mode. Keep this in mind. So cos inverse 19 over 648, so you will get 1.54 radian. So that is 1.54 radian. Okay, this is 2 decimal place, since they wanted what? Up till 2 decimal places. Okay, so the value for what? The angle ABE. This is the angle what? Angle ABE. This is equals to what? 1.54 radians. That's it. Okay. Okay. So this is question like part B, solution to part B. Next, the last question is part C. Find the area of the garden. We need to find out the area of the garden. Okay, giving you answer in meter squared to 3 significant figures. Okay, we need to give our answer to meter squared. Okay, fine. Okay, so area. Already we know the area of this what? Of this sector. We know the area of this sector already. We did this in part A. Now we need the area of this triangle, the scaling triangle ABE, and the right angled triangle BCD, right? Okay, so at first find out the area of triangle ABE. So how can you find out the area of triangle ABE? Using the formula that is half of what? AB sine theta. Okay, the area of triangle is what? Half of AB sine theta. Okay, for part C, which area? Area of triangle what? ABE, most probably ABE, right? It's ABE, correct, it's ABE. This is equals to what? Half of AB sine theta. What is what's AB? AB is the what? The two adjacent side to the angle theta. Okay, so we are considering this angle theta, right? So in that case, the adjacent sides are what? 10.8 and 6. Okay, so 10.6, is it 10.6? 10.8 and 6. 10.8 and 6 and times sine theta. Times sine theta is how much? 1.54 something radian. Okay, we got this in the previous part. So what's the value? Sine answer. Okay, sine 1.54 radian. So times 10.8 times 6 times half times 6 times half. Okay, so what you will get? It is 32.386 something. So 32.386006954 meters squared. I took the exact value. Okay, to get the exact answer. Okay, so area of triangle ABE, we got the area of the triangle ABE. Next is what's remaining? The area of the right angled triangle BCD. Okay, so in order to find out the area of triangle BCD, there's two options. Using the formula for like triangle, that is half of base times height, half of base times height. So base and height will be required, which is both of them are unknown. Second method is using the formula half of AB sine theta, half of AB sine theta, where the two adjacent side we will consider this angle as theta. Okay, we will consider this angle as theta and we will use these two adjacent sides. So that means we need BC. This is more easier, like it will be more faster because we just need to find out BC. So for finding BC, we have to find out this angle theta at first. How can we find out that? Since ABC is a straight line, so this is what? Pi radians. ABC is pi radians. So from pi radians, subtract 1.3 radian and 1.54 radian. Okay, so we need angle. Which angle we are talking about? That is DBC. Okay, or D angle DBC. This is equals to what? Pi minus 1.3 radian minus what? 1.54 radian. So what we will get? So pi 3.1416 minus 1.3 minus 1.54. So you will get 0.3016. So 0.3016 radian. So we got the angle DBC. Now we need to find out what? The length of the base, right? That is BC. How can we find out BC? Using cos theta, isn't it? So use cos theta. Theta is known. Cos angle DBC, it is equals to what? It is equals to adjacent side, that is we need to find out. This is what? BC, right? BC over the hypotenuse, right? That is 6. So length of BC would be what? 6 times cos 0.3016 radians. So what would be the value? That much meter. So the value would be cos answer times 6, that means this is 5.73. 5.729, I'm taking the exact value, 74605 meters. Okay, now the area of triangle what? ABC, isn't it ABC? It's BCD, sorry. This is BCD, area of triangle BCD, that would be what? Half of AB sine theta, right? So one is 6, one of the adjacent side is 6, the other one is 5.7 to something times what? Sine theta. So sine, how much? It was 0.3016 radian. So what would be the value for the area? So the area would be 5.7291 something times 6 times half times sine 0.3016 radian. Okay, so you'll get 5.10.55525.867 meters squared. Fine. So what we need? Area of the garden, right? Area of the garden is what? The sum of the three areas. Okay, the first area is the area of triangle ABE, that is 32.386 something. So that was what? 32.386 something plus what? Then the area of the triangle sector BDE, area of the sector BDE was 23.4. okay, it was 23.4. so 23.4 plus what? Plus the last area is what? Area of triangle BCD, right? Area of the right angle triangle BCD, that is 5.105 something. So if you add them up, what you will get? 23.4 plus 5.105 plus 32.386. So the total value is 60.89, but they wanted to 2 decimal places, isn't it? They wanted to 2 decimal places. Oh, sorry, 3 significant figures. Okay, they wanted to 3 significant figures. So in that case, the value would be what? The value would be 60. We got 60.891 something meters squared. So up to 3 significant figures, that would be 60.9 meters squared. This is what? 3 significant figures. That's it. And this is all about question number 5 from May 2024 P1 paper. That's it.